Hello there. We're doing 2004 question number 1. It's a calculator question. You'll notice I say it's an ETLT question, kind of. It's not really at all, but that's okay. Alright, let's go ahead and look at what we're doing. So, part A, for this question, I started by typing this into Y1 in my calculator. Then it says find the average rate of change. There are two formulas. There's average rate of change, and there's average value of a function. Now, average value of a function is 1 over b minus a integral a to b f of x dx. That's average value of a function. That's not what we're talking about here. And in fact, this is not on your AP exam this year. They got rid of it, this one type of question. Average rate of change is average. Rate of change means slope, so this is average slope. So this is f of b minus f of a over b minus a. Okay. So in this problem, we want the average rate of change of a from time 0 to 30. So it's a of 30 minus a of 0, okay, like this, over 30 minus 0. Now, a of 30 you're going to find in your calculator by taking a 30 and plugging it in here, and then you're going to plug a 0 into here, or you can use your hotkeys. But if I use alpha trace and I do y1, and I can do y1 parentheses 30, I can type this in. So here I have 0.78292. A of 0, if I type that in my calculator, is 6.687. And then over 30 minus 0 is just simply 30. And if you type all this into your calculator, you will get the answer of negative 0.197-ish. Now, they also ask for units. If you get the answer without units, they actually give you no points. They need answers and units both to give you the points. Now, just look at what we subtracted. What did we subtract on top? A of 30 and A of 0. If you read the problem, A of those right there are dealing with the amount of grass clippings in days. So this is pounds. Right here, A of t is measured in pounds. So on top we subtracted pounds, and then on bottom the 30 and the 0 are in days. So this is pounds per day. And that's answer 1. Again, grass clippings, days. Alright, I'm going to go ahead and erase this. And we'll go to part B. Alright, part B says find a prime 15. Now thankfully this is a calculator question, so since I put this in A in my calculator, okay, y1 is A of t. So I can use hotkeys, but all I want to do is use my calculator and take the derivative of what's in y1, or you could write this whole equation. I want to take the derivative of this, and then take that derivative at time equals 15. So again, I'm going to use hotkeys here to speed things up. Math 8. I'm going to use my hotkeys y1 at time 15, and I get negative 0.1635. Okay, now they want to know for this question, what does this mean in terms of the problem? Now, first of all, we took the derivative with respect to time. So this right here, this answer is pounds per day. Alright, so remember from the last question the 3 things you need to talk about. You need to talk about time, that's 15. So I'm going to start by saying at time equals 15. By the way, I'm describing what it means because the question says, with correct units, interpret the meaning of the value in the context of the problem. So at time equals 15, then this is the amount of grass per day. So the amount of grass is, and I'm going to use this negative. This negative tells me it's decreasing, so is decreasing at a rate of 0.1635 pounds per day. So we talked about time at time equals 15. We talked the word increasing or decreasing based on the positive or negative, and then answer with units. So at time equals 15, the amount of grass is decreasing at a rate of 0.1635 pounds per day. Okay, question 3 says, find the time t at which the amount of grass clippings is equal to the average amount of grass clippings. So, the question is, when is the amount of grass clippings equal to the average? Notice this doesn't say average rate of change, it says the average amount of grass clippings. That's this formula. So let's start with the average amount of grass clippings. So the average amount of grass clippings on the time interval 0 to 30 is 1 over b minus a, integral from a to b of f of x dx, but instead of f of x, it's a of t. And if I type this into my calculator, I will get an answer, and it's calculator section, so they want us to type this in, and we will get, they don't tell me, I have to type it in. So 1 over 30 math 9, 0 to 30, and I'm going to use my hotkeys. Alright, and this gives me 2.7526-ish. Okay, that's the average amount of grass clippings, 2.7526. The question is, when will the amount of grass, this is the equation for the amount of grass, equal the average amount of grass? So the question is, when will the amount of grass, so that's this equation, equal the average amount of grass? By the way, I forgot to mention, those of you who are following along up here, this is part C. So if you just tuned into part C, you might have to rewind it a little bit. Sorry, this is part C. We've been talking about it for quite a bit. Okay, so I need to know, when does the amount of grass equal the average amount of grass? Now, if I want to know when are these two equal, there's two different ways of doing this. I can graph this in y1 and this in y2 and just figure out where they intersect. So that's what I'm going to do. I got this in y1. I'm going to plug this answer in y2, 2.7526, and I'm going to graph them. And I might, there you go. I didn't make my window far enough. This is from time 0 to 30, so I'm going to adjust my window from time 0 to time 30. And if I adjust my window from time 0 to time 30, one of them looks like this, then the other one looks like this. And we're trying to find out where they intersect. So second calc intersect, and I get an answer. This equals this at time 12.4149. So 12.4919 is my answer. The other thing you could have done is you could have moved this to the side. This is already in y1 and in your calculator. So if you would have moved this, oops, can't do that. If we subtract this to the other side, I mean, we already got it right, but if you subtract everything to one side, instead of putting this in y1 and y2 and look for the intersections, if you move them to the same side, you can graph and look for the zeros of the graph. And it will cross the x-axis at the same time, which is 12.4149. Alright, that's part C, and now let's go to part D. Alright, part D says The linear approximation at time equals 30 is a better model for the amount of grass clippings further remaining in the bin. Use L of t to predict the time at which shall be 0.05 pounds of grass. Okay, so we need to write an equation of, they said, a tangent line, right? They say the linear approximation, it is a better model, L of t, the linear approximation, or a linear approximation is using a tangent line. So they want us to use a tangent line. Linear approximation makes a line. So we want to know at time equals 30, what's the equation of the tangent line to the graph of A? Now, what two things do you need to write the equation of a tangent line? You need a point. So what's the point at time 30? And what's the slope? So point and slope. Now, remember, I have a graphing calculator, and I can use hotkeys. But all I'm going to do is I'm going to plug a 30 into A of t and find out where I'm at. Now, I'm going to use y1 and then put parentheses and type in 30. So I get 0.7829, and then I need my slope. So I'm going to hit math 8, tell my calculator to take the derivative of what's going on at 30. So I'll do d dx, plug in 30, and I get negative 0.05597. Now, this is the point. So my equation is y minus y1. Remember, this is the x and the y, or the t. This is t and whatever, but y minus y1. Except here in this problem, my y's are actually a's, if we want to put an a there. Equals m, the slope, and then x minus x1. But instead of an x, we're using t, so t minus t1. So it's y minus y1 equals m times x minus x1, t minus 30. And we're going to move this to the other side. So we get negative 0.05597 t minus 30 plus, because I'm adding this to the other side. And once I have this by itself, instead of calling this a, they've told me to call this L of t. So this will tell me, so instead of a equals, L of t equals, instead of y, L of t. Okay, great. And then they say, great, now use this equation. So we got this equation to predict when there will be 0.5 pounds of grass left. Well, this is what's left. So I'm going to put a 0.5 there. Okay. So I put a 0.5 there, and I need to solve this equation. Now, folks, I don't feel like solving this. I'm going to plug this in y1, this in y2, and I'm going to graph and find out where they intersect. Could I distribute and solve? Sure. Could I move this 0.5 to the other side and have it set equal to 0 and graph and find out when does what are the zeros of the graph? Sure. But if I just plug this in y1, this in y2, and look for the intersections, it will give me the answer. And that intersection is going to be 35.054. Okay, well, that's it. That's a pretty tricky question, but I hope part of it made sense, or at least where the formulas came from. All right, thank you. Bye.